so now we're going to use the significant digits with operations. So the first one, if you add or subtract, the answer is rounded to the same number of decimal places as the measurement with the least number of decimal places. Okay, so before we move on to multiplication or division, let's do an example for this. So here, we want to look at the decimal place. So we have 2 decimal places here, we have 1 here, and we have 0 here. Okay, so when we calculate it, I'm just going to get my calculator. We add them up, 12.01 plus 35.2 plus 6. And we get 53.21. So I'm going to write this out first. 53.21. And then that's milliliters. Remember your units. Okay, so we need to have 0 decimal places. That means I need to get rid of these 2. So I'm going to look at right here. This is all I want. And that 3, if it's 5 or above behind it, then it will round up. Or if it's 4 and below, it will round or stay the same. So this, I'm going to put it in brackets, my significant digits would be 53 milliliters. Okay, so then another one here, subtraction. I have 2 decimal places here and 1 decimal place here. So when I calculate it, I get I get 26.56. And that's grams. Okay, so I only want 1 decimal place, so I only want up to here. So I look at the number behind it and it's a 6, so that will round my 5 up to a 6, so I get 26.6 grams. Okay, so that's addition and subtraction. So my next one is if you multiply or divide 2 numbers, the answer is rounded off to the number of significant figures and the least significant used in the calculation. So pretty much it's the number with the fewest sig figs, and the question is what you round your answer to. So here I have 3 significant digits, and here I have 4. So remember, when you're multiplying or dividing, you need to count all the significant digits, and it's no longer just the decimal places. Okay? Where adding and subtracting, you're only looking at how many decimal places there are. So here I have 3 sig digs, here I have 4. So that means my answer needs to be rounded to 3 sig digs. So 1.35 times 2.467, I get 3.33045. Okay, and that's meters times meters, I get meters squared. Okay, so I need 3 sig digs, so I start here. That's my first sig, my second, my third. So I want to stop it after that 3. Okay, but I have to always look at what's behind it. Remember, if it's 5, 6, 7, 8, or 9, that will round up. If it's 0, 1, 2, 3, or 4, then this will stay the same. So since it's a 0, it will stay as 3.33 meters squared. Okay, so this one, that's actually a division sign here. So I have 1035 divided by 42. And I get a very long number. So 24.642857114, and meters squared divided by meters. So you got to think of your exponent rules. I get meters. Okay, so here I have 1, 2, 3, 4 sig digs, because remember, non-zero digits are significant, and then significant sandwich would make 0 significant too. So here I have 4 sig digs, and then here I have 1, 2. So that means my answer needs to be rounded to 2. So that's my first, that's my second. So then I look at the number behind it, which is a 6. That would round my 4 up to a 5. So then in brackets, I get 25 meters. Okay, and that's what you do when you have operations with sig digs. So now flip it, we're going to do some scientific notation. Okay, so in science we deal with very large numbers and very small numbers. So this is just an easier way to handle those numbers. So what you do is you want to bring that decimal point after the first whole number. So I want to bring that decimal point here. So I got to move it over 1, 2, 3, 4, 5 times. So I get 3.47. So originally, without that decimal point, there was only 3 sig digs, the 3, the 4, the 7, because those zeros without the decimal place would not be significant. So I need to keep 3 sig digs here, and then you moved it over 1, 2, 3, 4, 5 times. So that would be times 10 to the positive 5. Okay, so a little rule, so the times 10 part to the y, if y is positive, then it's a large number. But if y is negative, then it's a small number. Okay, so here we can see this is a large number, and if I covered that decimal point up, you would see that this is significant and this is significant. Those zeros without the decimal point are not significant because they're just space in the decimal point. But significant sandwich here would make that 0 significant too. So I need to keep all my numbers that are significant in scientific notation. So I'm moving the decimal place over 1, 2, 3, 4, 5, 6, 7, 8 times. So I keep my 3 sig digs times 10 to the 8. Okay, and again here, without that decimal point, I would have 3 sig digs, the 6, the 1, the 4. So I need to keep those, and I'm moving it over 1, 2, 3, 4 times. So I get 6.14 times 10 to the 4. Okay, so now if we want to take scientific notation and expand it, so we start off with scientific notation and we want to end with a number that's expanded like these. So I can write it as 1.23 for now. So that times 10 to the 5 means that it's going to be a large number since it's a positive 5. That means I need to move to the right in order to turn it into a large number. So I'm going to move 5 times. 1, 2, 3. So every time you go another spot and there's nothing there, add a 0. 4, 5. Okay, that would make it 123,000. Okay, and again here I have 6.806. It's a positive number, so I'm going to move it to the right. 1, 2, 3, 4, 5, 6. So I get 6,806,000. So that's my number there. Okay, so an additional one I'm going to add is for a very small number. So say I have, so that's a very small number, okay? And I want to turn it into scientific notation, so I don't have all these zeros in it. So I'm going to be moving this to the right. 1, 2, 3, 4. And you always want it to come after the first whole digit, first whole non-zero digit. So I want to bring it over after my 2. So I moved it 4 times. So I write it out 2.33. So I keep my 3 sig digs because those are not significant because they fall in the decimal place, but there's not a non-zero digit in front of it. So I have 2.33 times 10. So since this is a small number now, we got to use a negative exponent. So we moved it over 4 times. That will make this 2.33 times 10 to the 4. Okay, and that's all you need to know about the scientific notation.